Number 6. So the function y equals x cubed ax squared b has a minimum squared at 4, -11. We don't have a fully defined function here. There's two unknown constants. We are supposed to find the coordinates of the maximum points and the value of b. Not sure why they don't think we need to find the value of a as well, but let's get started and see where we go from. So I know there's a minimum there, which means I know that y prime when x equals 4 is 0. And I also know that -11 is 4 cubed plus a times 4 squared plus b. So by knowing this point, I already have two pieces of information. Let's find that first derivative. Y prime equals 3x squared plus 2ax, and the b disappears. So let's plug in 4 and set it equal to 0. So 0 equals 4 squared is 16 times 3 is 48. Plus 2 times 4 is 8. That's 8a. So a equals -6. That allows me to come back to this equation and plug in the -6, which should find me the value of b. We have -11 equals 64 minus 6 times 16 plus b. I'm doing this by hand. I want to put this back. I know that this is 4 times 16, and that's going to make that subtraction easier. So this is -11 equals -2 times 16 plus b. If I add 32 to both sides, 21. I found the value of b. That's already part of the question. And it also wants us to find the coordinates of the maximum points. This means there's another value of x where this first derivative equals 0. So going back to the first derivative, let's put in what we know a is and solve when it equals 0. So 0 equals 3x squared minus 12x. So 0 equals 3x times x minus 4. The two solutions are x equals 0 and x equals 4, but I already know that this one is a minimum. Of course, that doesn't necessarily mean the other one is a maximum because this is a cubic function. I know it looks like this. So I know this first one is going to be a maximum, and it's going to be at the value x equals 0. It says coordinates plural. The thing we already found out what b is, because when we plug 0 into the y function, so our maximum is 0, 21. When you plug in 0, the x cubed and the x squared terms will both disappear.